Hello everyone, my name is Jordi Gillio and my group is going to talk to you guys about the Airbus A400 conceptual airplane. Everything started when Hogan advertised the concept of the Airbus in 1959. He said that the airplane was going to be able to hold around 126 passengers. In 1973, the oil crisis affected all the airlines, which made Airbus go to bankrupt in 1975. However, in 1980, Airbus was saved by the Eastern Airlines orders. In 1987, the A320 was finally shown in public for first time. In 1994, Airbus started developing their own large airliner named A3XX. In 2011, Airbus established orders of $72 billion for 730 aircraft, making a new record in the civil aviation industry. Some of the innovations that Airbus had was the A300, that was the world's first twin-engine, twin-aisle passenger jet with around 230 seats. They also had the A320, which was twin-engine but single-aisle, and it was able to hold 150 passengers. After that, they got the A340, which had 4 engines, twin aisles, and hold 330 seats. And the final one they made was the A380, 4 engines, 2 aisles, double deck with 555 seats.
Hello everyone, my name is Castillo, and I was in charge of providing the interior design layout and the in-flight entertainment and connectivity features of our Airbus A400 conceptual airplane. Now this airplane will be sporting 3 cabins, a lower level, a main deck, and an upper level, all of which are interconnected by escalators, one located at the front of the plane, one in the middle, and one in the back. The lower level is comprised of 40 pod-like seats, which are geared towards providing your business class owners with the most amount of space and comfort possible. Their chairs will be fully reclinable to transform into beds. They will also have a workspace area right next to them, and they will also have a TV tablet directly in front of them, which they can use to take on the go or to surf the web. Now the middle portion of the lower level has the wing, which separates the front from the back. The back has the kitchen, which will be used to prepare all of our passengers with the best quality of food, and the sleeping quarters for the cabin crew, which is comprised of 20 bunk beds that come out of the walls. The main deck is comprised of the cockpit at the front and 400 economy class seats towards the back. Now, I know 400 may sound like an alarming number, but these are our widest seats to date, and it provides each one of our passengers with stowage area right next to them and above them, as well as a bunch of legroom. Now, the middle portion of this main deck has laboratories for men and women, as well as handicapped men and women. Now this connects to the upper level, which is comprised of 10 private first-class rooms that are located at the front of the plane. Each one of these rooms will have an L-shaped sofa/bed, as well as a desk to do some work and a TV tablet. This connects through a corridor to a 5-star buffet restaurant, which is located in the middle of the upper level, which is open to all passengers at a flat rate of $30. And this connects to the back portion of the upper level, which is an air mall for all passengers, which allows them to walk around and shop. We have an Apple store, a Brookstone, a convenience store, and a liquor store. Just in case somebody left something behind, they can always just go to the convenience store and pick something up. Now, let me talk about the in-flight entertainment and connectivity. Each one of our passengers will have a TV tablet which they can use to make commands. For example, if they wanted to place an order for food or for merchandise from the air mall, or to call the cabin crew. They can even use this to watch TV, surf the web, or use apps, all through the free Wi-Fi that we support for all customers and passengers on our Airbus A400 airplane.
Hello everybody, my name is Jeancarlo Casasola and I'm the last member of Team H. I was actually in charge of the actual design of the plane, and a couple of the aspects that we wanted to attack about the plane were fuel efficiency, meaning instead of using gasoline or petroleum, we use something like lithium batteries, hydropower depending on how the technology for that is in the future, and then solar power, even though it is efficient, but it's very costly to make. Also a slimmer body, that means that the shape of our actual plane is way different from planes nowadays. Our body has a lot more curves to it, a couple different features behind it. One of the more important features is the wingtips. The wingtips itself are in the shape of a Y. The Y being so that, to apply less drag force on the plane itself. And then finally, going along with fuel efficiency, we wanted our plane design to be less dependent on the engine itself. Now, to further explain the wings are actually pushed back on the body, and they're a lot longer than most models, and they do not have the engine turbines attached to them. Now, the reason behind all of that is because we wanted our plane to glide into the landing strip rather than to have the thrust from the engine kind of push the plane to landing. Depending on the material that we choose to design the wings with, we were thinking about aluminum alloys or some type of composite material like carbon fiber, because the longer design of the wings actually we wanted to kind of like flex while it's in the air, so it flies smoothly towards the air. And then the engines itself are actually, like I said, they're not mounted towards the wings, but they're actually part of the main body towards the back. And then that is also, so the plane itself isn't as dependent towards the engine. And then finally, the last part is the wingtips. Now the wingtips, as I previously stated, are in the shape of a Y. The reason behind that is so that the drag force that's being applied on the airplane while it's in transit is decreased. Now most planes nowadays are able to travel at a maximum height of 30,000 feet and a maximum speed of 85% the speed of sound. Obviously, if they exceed that speed of sound, there's kind of some turmoil like within the body itself, within the infrastructure. So our plane design, we kind of want to make it a little more, a couple more curves on it, as you can see from the SolidWorks design, so it can kind of flow through the air. And then the last part that we had in mind was how to read the actual speed that the airplane is going at. Now, for the last 100 years, the speed for the actual airplane is measured through a pitot tube, which uses the Bernoulli equation to kind of measure the speed of the fluid flow going through it. Now, we were trying to think of something different because, as we all know, there's been various incidents where the pitot tube is actually clogged up through ice or through debris, and it ends up with a wrong reading on the gauge for the actual pilot, and then there's been a couple crashes actually. So we were trying to think of a different technology to measure the speed of the actual airplane.